nice to be back here after 4 years. This talk, this presentation, is a sort of continuation of what I talked about 4 years ago. So in case there are people here who don't specifically remember that, although I'm a physicist, I've been developing a whole bunch of physics toys based on mathematical constants. The MAA put out a nice book called, the title is Phi, Pi, E, and I. Presumably that's because they're the most important mathematical constants. So I had started out in this project making a thing that I called the phi top. And I'm not going to spend time going over this again, but the thing is sitting here. It's a prolate ellipsoid. I optimized the shape so that it can stand up, and it can stand there and spin for maybe 8 minutes. And after I had developed the phi top, I said, well, we need a pi top. The pi top, I have it fiddling around over here. It's a right circular cylinder. I did a lot of physics experiments to optimize what you might call a spinning toy or a coin or precessing coin. And as you can see, the thing just precesses and precesses and precesses. And it eventually, yes, it goes to a finite time singularity at infinite frequency, as you can hear in a moment. So I introduced the pi top 2 years ago. Now, having done the pi top, I said, well, we've got to have an e top. What would an e top be? Well, the phi and pi were built into the first two objects. The e-top, well, I didn't optimize the physics. I just was ornery and said, I want an e-top. What is that? Well, it's a top, which is an oblate spheroid. And as with the phi top, I can do a demonstration, Tesla's egg of Columbus, except now it's Tesla's e-top of Columbus. And so this thing will spin by inducing it with a magnetic field. You can see the cross-section looks more or less like the phi top. So now we have a phi top, a pi top, and an e top. What's left? We've got the e top here. What's left? The imaginary top. Now, what are you talking about when you say imaginary top? Well, there is a book about it, The History of Imaginary Spinning Tops by Nick Dantock. If anybody knows his wonderful Griffin and Sabine, this is actually a chapter in the Museum of Purgatory. That's where it clearly belongs. So imaginary tops, what could that be? Well, I gave up because a real imaginary top is, well, hard to imagine. But in its place, I designed something else, which is a quasi two-dimensional inverting top. So I switched the I from imaginary to inverting. So this object, which you can see over here, but I'll spin it in a moment. If you spin it with the heavy side down, it turns upside down and spins in the opposite direction. It's a quasi two-dimensional tippy top, if you want to think about it that way. And you're going to all be able to play with these things upstairs in one of the rooms up there. So I've designed a suite of 4 tops, phi, pi, e, and I, for all of these major constants. What is it that connects these? Well, oddly enough, what you're going to see here is not in that book by the MMA. I don't know why not, but anyway, here's Euler's identity. Most of you just think about EI and pi. But the definition for phi is 1 over phi minus phi is minus 1. So obviously, you can substitute in the first equation, and you get what I would like to call the EI pi phi relation. It's not Euler's, but it's what it is. And here is my physics version. This is the Sirius Enigmas physics identity. E to the I pi is 1 over phi minus phi. How much time do I have left?
90 seconds.
So, you think that's all there is here, but 2 more. In honor of G4, G14, 2 years ago when we were going to do this, I designed a 14-sided top. And it's a cube octahedron, the very same one that you see that Leonardo illustrated for Pacioli. I'm going to have to switch over here for a moment to the Tickle Me Elmo. So can I have the Tickle Me Elmo going? So that 14-sided top is here. I have a second version of it over here. Again, you'll be able to play with this yourself. But I can spin this thing. Whoop! Ah! Blew the demo. Anyway, you'll be able to play with it yourself. You can spin it, and it'll spin for 10 seconds. Now, there's one last thing that I'd like to introduce. 30 seconds. Can we switch to this computer for one moment? In the summer of 2019, one of my best friends in life, Mitchell Feigenbaum, passed away, and I was invited to speak at his memorial. Mitchell had discovered the only constant of any living person named for them. It's the Feigenbaum Constant, and it is the constant that determines the period doubling rate for chaotic systems. Anyway, I decided to design the delta Celt, a dynamical system which turns in the opposite direction when you spin it. This thing builds in delta. You can add weights, you can change its performance, and it's what I've called the delta Celt. Everybody has on the table a little bookmark about it. And in addition to that, everybody will get in their gift exchange a decision maker where you can use a Celt to make decisions for you.